Hey, Bogdanovsky here. Slope in linear function context. Did you know that finding slope is very easy, and we're going to break down for you in this video. So let's dive in. So if you want to find a slope from the graph, the first thing you must observe is that you have two identifiable points. So you have to have a point that you can quickly identify. Let me grab my magic. So I have to have a location of one point, and I have to have a location of another point. It doesn't matter how far apart, whether they have coordinates in terms of real numbers with fractions, what have you. It doesn't matter. As long as you know that I have a one point with coordinates, I have the second point with coordinates that belong to the same line, you're at the best spot ever. So this is the spread along horizontal distance. This is the spread along vertical distance. So the slope is defined as that difference divided together, right? Delta y divided by delta x. There's a formula that sort of shows you that you find 1 minus second. We're going to show you momentarily. Sometimes you will see a situation where the line looks like this. So as you remember, we always measure the process or observe the pattern as you scan left to right. So the horizontal change is always run. Simple, okay. Moving away from the origin to the right, boom. But then the change, the vertical change, sometimes, because when you start here, will be called a negative rise, or I could call it a fall instead of rise. So this coordinate, when you identify it, and coordinates of the other point that you want to use for the calculation would represent the spread along y values divided by the spread along x values. So let's see how that works in broader application. So the slope is always connected with a linear function. So that concept cannot be separated. When you have a slope of a line segment, that represents a broader picture that there is a line, and line segment is just a segment, it's a portion of that line. So as long as you would remember the change in y values divided by the change in x value. We call it rise over run, typically, and this is the formula that represents the ratio, and the top is always the same. Y coordinates are being implemented for the numerator, x coordinate for the bottom. Sometimes students switch this, so that's the common mistake. I've seen it time and time again. So as long as you establish that the top is the y, the bottom is the x change, you're good. So you may have a different signs, right? We talked about that discussing the ratio. Positive slope, right? So the line is increasing, the function is increasing. You may have negative slope, or you have a zero slope. There is a confusion here in terms of the zero. Students tend to say, if the slope is zero, they say the slope doesn't exist. It does exist. There's a vertical line where the slope is undefined because we cannot calculate, because there is no difference in y values. No, the difference in y values does exist, but there is no difference in run, so you cannot divide by zero. So this is the case where the slope is unidentified, as opposed to the zero slope where the slope does exist, but the value is zero. Hopefully this makes sense. And this is sort of the visual. Positive slope, the line is rising. Negative slope, the line is falling. And zero slope, the line is horizontal. So let's drive it home. Those are the possible values of the slope, like real numbers. If we have a real number, that means that number can be pinpoint. You can identify the value for that number. Positive, negative fraction, rational, irrationals, we don't care. But the number does exist. If the number does not exist, then we say the slope does not exist. All right, so quick application of the slope formula. As I said, we have to have 2 points. The points have to be separated. If you duplicate the same point, if you repeat it twice, then you're not going to find a slope, because through the 1 point you can shoot many different lines in many different directions. So you have to have 2 distinct points. You identify coordinates for each point. So for example, point A with 1 and 2, point B with coordinates 5 and 10. Now, for your own sort of a benefit, call it x1, and this would be corresponding y coordinate y1. So the second will be x2 and y2. Now, it doesn't matter whether A is first and the B is 2, because you can call it, I want this to be 1 today, and this coordinates to be 2, number 2. And then you switch the values, and then you still do the same way. You find the rise, the difference in y values, divided by the difference in x values. So let's walk through that. So you substitute 10 minus 2 divided by 5 minus 1. Those are the only numbers that you can use, because those are the only numbers that are provided. So we're not inventing any other values. And then you simplify, boom, you have the slope. So the slope is 2. The slope does not come with any unit rate. It's just a pure number. So as long as you continue remembering delta y over delta x, y2 minus y1 divided by x2 minus x1, you can also say y1 minus y2 divided by x1 over, if I have in that fashion, I always do the right thing as well. You can do that. First minus second, first minus second. It doesn't matter. As long as you do them consistently in the same direction. If I go 2 minus 1 coordinate, the second minus first coordinate at the bottom. That is the key. So this example illustrates, if I were to label those points in different direction, right? I would say that B is the first and the A is the second. I still do the ratio, rise over run, that doesn't change, 2 minus 10 and 1 minus 5. Please note, 10 minus 2 over 5 minus 1, as opposed to 2 minus 10, 1 minus 5. So I get the negative 8 over negative 4, but when you divide both negatives, you get the same thing. So those two slopes are the same. So hopefully now you are master of finding a slope between any 2 points, whether you have them on the line, whether you have them in form of a chart. For example, this chart again represents a change that you have to establish first, that the x values continue changing by the same number. So that's the key. It doesn't matter whether you have a table and then you make an assumption, then you are not doing the right thing. So think for yourself. Make sure that the column X shows constant change. Whether it's increasing, decreasing, we don't care. Must be constant. Then you do the observation and say, okay, this is the change that looks the same because I have 3. So that you already know that the slope should be 3. But let's say if you didn't know that, you grab any 2 points. If you do 9 and 6, right? So the difference between 9 and 6 will be divided by the difference between 2 and 1. Boom. You can do the 12 and 6. So any 2 points, 12 and 6. So then the bottom will be 3 and 1. So hopefully this makes sense. Any combination. And also you can do them in the opposite order. 3 minus 6 divided by 0 minus 1. As we showed you on the slide above. In any case where you complete the ratio, you'll find 3 as a final answer. So as long as you drive home the concept that you do the vertical change over horizontal change and you consistently apply the difference in the same direction, you're good. You don't have to see the graph. You just have 2 points. without even having a table of values. You find the slope, and based on the value of the slope, now you can predict where this line is going. Is it rising from left to right, or is it decreasing from left to right? So hopefully this video makes sense. You do the practice questions as usual. If you don't, you're not learning as much. Hopefully you can share that video. We'll see you again. Bye for now.